Welcome. Find a comfortable spot, settle in, and prepare to drift off to sleep. Imagine the silent, profound darkness of space. Among those billions of stars are those that have long since died, but their death was merely the beginning of a strange new life. What if it was there, orbiting the burnt-out husk of a giant star, that humanity first encountered something truly inexplicable? Tonight's sleep journey is dedicated to one of the greatest enduring mysteries in astronomy. It's the story of strange signals emanating from a neutron star that forced scientists to ask, was this a simple coincidence, a unique natural phenomenon, or was it something more? Perhaps the deliberate observation of something non-human? We'll take a trip to a distant pulsar tonight to try and understand what really lurks in its orbit. An unidentified flying object, or GT, simply the greatest observational mistake ever made by astronomers. Let's explore this together as we slowly drift into slumber. To truly understand the heart of tonight's story, we must first get acquainted with the main character. It's not a person, but a celestial object of truly unbelievable nature. It is called the neutron star. Imagine a star many times more massive than our own sun. At the end of its life, it explodes, becoming a supernova. This explosion blasts the outer layers of the star into space, but what remains at the core begins to collapse under the influence of monstrous gravity. The core shrinks to such an extreme degree that electrons are forced into protons, forming neutrons. That is how a neutron star is born. It is a tiny sphere by cosmic standards, only about 12 miles, 20 kilometers, in diameter. Yet contained within that sphere is a mass exceeding that of our entire sun. A single teaspoon of neutron star material would weigh billions of tons. Some of these stars spin at tremendous speeds, emitting narrow beams of radio waves from their magnetic poles. These beams sweep across the universe like the searchlight of a cosmic lighthouse, and if such a beam happens to cross Earth, our radio telescopes register it as a perfectly precise, repeating pulse. We call these objects pulsars. Their timing accuracy is comparable to atomic clocks, and it is precisely such a pulsar known as PSR B1257+12 that became the source of our mystery. The story begins in 1990. Polish astronomer Aleksander Wolszczan was working at the renowned Arecibo Observatory, analyzing data streamed from the pulsar PSR B1257+12. This stellar corpse, located in the constellation Virgo, reliably broadcast its signals. Pulsars are known as the cosmic gold standard for accuracy. Their pulses arrive with predictable, almost flawless periodicity. Any deviation from this schedule immediately catches a scientist's attention, and Wolszczan noticed something strange. The arrival time of the pulses from his pulsar was subtly, yet systematically, shifting. The signals would sometimes arrive late and sometimes a little too early. It was as if an unbelievably precise clock had suddenly started skipping beats. In the high-stakes world of astronomy, where everything relies on the precision of measurements, an anomaly like this was completely unheard of. The immediate thought, naturally, was error. Equipment malfunction, calculation mistakes, or interference from terrestrial sources. But tests, repeated again and again, confirmed that the telescope was operating perfectly. The mystery wasn't here on Earth, it was out there in deep space, more than 2,000 light-years away. What could possibly explain the erratic behavior of this cosmic beacon? The answer lay in the fundamental laws of gravity. Astronomer Aleksander Wolszczan proposed that the pulsar wasn't alone. Something massive must be orbiting it, its gravitational pull subtly shifting the star's position. When the star moves slightly toward Earth due to the influence of this unseen object, the radio signal's path shortens and the pulse arrives early. When the star moves away, the path lengthens and the pulse is delayed. This is a well-known phenomenon called the Doppler effect. By analyzing the precise nature of these fluctuations, researchers could calculate the mass and orbit of the invisible companion. Wolszczan's calculations, however, led to an astonishing conclusion. Orbiting the dead star were not one, but at least two bodies, and their masses were comparable to that of planets. This was a massive sensation. Until this moment, humanity had never confirmed the existence of a single planet outside our own solar system. And now they had found two at once, orbiting the most unlikely location imaginable, a pulsar that had survived the catastrophic hellish blast of a supernova. The very notion seemed absurd. How could planets possibly survive such a cataclysm? Or perhaps had they formed only after the explosion? The scientific community greeted this news with immense skepticism. The notion of planets orbiting a pulsar was so radical, so bizarre, that most astronomers immediately dismissed the findings as erroneous. Just prior to this, another research team had announced a similar discovery, only to be forced to retract their paper. They had failed to account for the Earth's orbital motion in their initial calculations, which created a false, illusory planetary signal. The consensus was that Wolszczan's finding would meet the same fate. Everyone expected a simple, terrestrial explanation, for the anomaly would soon surface. The pressure on the scientist was colossal. He faced a stark choice: either validate his findings to the entire world or concede one of the most embarrassing errors in the history of astronomy. But Wolszczan remained resolute, confident in his meticulously collected data. He pressed on with observations, steadily building a case that supported his original hypothesis. The fluctuations in the timing of the pulsar signals were too regular, too complex, to be dismissed as mere noise or error. They clearly indicated the gravitational interplay of an entire system of orbiting bodies. The world held its breath, awaiting the final verdict. Could the very first exoplanets truly be found, circling such an astronomical hellscape? In 1992, Aleksander Wolszczan and his colleague Dale Frail published a groundbreaking paper that fundamentally changed our view of the cosmos. They presented undeniable evidence for the existence of two planets orbiting the pulsar PSR B1257+12. A third, even smaller planet was later confirmed as well. This marked humanity's first ever confirmed discovery of worlds beyond our own solar system. The great irony was that these worlds were found precisely where we least expected them, not orbiting a tranquil, sun-like star, but locked to the rapidly spinning corpse of a supergiant, blasting the surrounding space with harsh radiation. These planets were given grim, mythological names: Draugr, Poltergeist, and Phobetor. Names associated with the undead and fear were perfectly suited for these desolate worlds born from stellar ash. But the main question remained unanswered. How did they get there? Where did a dead star acquire planets? This mystery spawned two primary scientific theories, each one almost equally improbable. The first theory suggests they are survivor planets. Perhaps the star had a planetary system before the supernova explosion. When the star expanded into a red giant, it would have consumed the inner planets, but the distant gas giants might have survived the initial expansion. Then came the explosion itself. The colossal shock wave should have instantly ejected any remaining worlds from their orbits. However, this theory proposes that under extremely specific conditions, the supernova explosion could have been asymmetrical. If everything aligned perfectly, the rocky cores of the former gas giants might have remained in stable orbits around the newborn neutron star. This is a scenario requiring an incredible, near impossible alignment of events. There are simply too many ifs. The chances of this happening are astronomically low, and most scientists consider this entire hypothesis highly improbable. After all, even if the planets had miraculously survived, their orbits would be highly elliptical and unstable, not nearly perfect circles as we see with the Wolszczan planets. That's why astronomers tend to lean toward the second theory, which is arguably even more astounding. The second hypothesis is known as the second-generation theory. This proposes that the planets formed only after the star had died. When the supernova went off, it hurled massive amounts of stellar material into the surrounding space. Crucially, some of this ejecta didn't fly off into the cosmos forever. It was captured by the powerful gravity of the newborn neutron star. This material coalesced around the pulsar into what is known as a residual or debris disk. This disk is very similar to the protoplanetary disk from which our own solar system formed billions of years ago, and it was right here, in this ring of stellar ash, that the planet-forming process began anew. Over the course of millions of years, these particles of dust and gas slowly clumped together, growing into larger and larger objects until the three rocky worlds we observe today were finally sculpted. This theory is generally viewed as much more plausible. It elegantly explains why the planets maintain stable, circular orbits, and it accounts for their observed composition. We are, in essence, watching a planetary rebirth, a brand new system rising from the stellar rubble of the old. But even this seemingly elegant and sound theory leaves a lingering space for doubt and, perhaps, for alternative ideas. And this is where we get to the really fascinating part. We're crossing the line where hard science meets speculation, the kind of speculation some people would call pure science fiction. What if the anomalies detected in the pulsar signals aren't caused by planets at all? What if it's something else entirely? This idea emerged almost immediately after the discovery. The signals were simply too precise, too sharp, too incredibly stable. Nature is certainly capable of creating wonderfully exact mechanisms like pulsars themselves, but an entire planetary system operating with such flawless dynamics, this led some to ask, could this signal be artificial? Are we looking at a techno-signature, a clear sign of intelligent civilization activity? This hypothesis immediately brings us into the realm of UFO speculation. Not in the sense of a classic flying saucer, but in its original meaning, an unidentified flying, or in this case, rotating object. An object whose true nature we still don't fully understand. And if it is artificial, who built it, and why would they place it in such an isolated location? Let's take a moment to imagine that these objects aren't planets at all. Instead, they are artificial constructs orbiting a pulsar. What purpose could they possibly serve? One of the most popular theories is that they are an energy station. Neutron stars, especially young ones, possess colossal rotational energy and incredibly powerful magnetic fields. A super-advanced civilization could potentially harness the pulsar as a gigantic power generator. They might construct some kind of megastructure around it, perhaps a Dyson sphere or a similar variant, designed specifically to capture the star's energy. These gigantic constructs orbiting the pulsar would create the very gravitational perturbations we mistakenly identified as planets. Their calculated mass, conveniently, fits the observations perfectly. Such an energy source could power a civilization for millions, perhaps even billions of years. This is a massive engineering project built by a civilization for whom stars are not mere points of light, but actual resources, and we may have stumbled upon their power plant by accident. But there's another equally compelling hypothesis. What if it's not a station, but a beacon? Pulsars are perfect transmitters for interstellar communication. Their signals are powerful and stable, capable of traveling across the entire galaxy. If you wanted your message to be guaranteed noticed, you wouldn't send it from some random star. You'd choose a pulsar instead. Perhaps an ancient civilization deliberately placed massive objects into this pulsar's orbit. Their purpose would be to modulate its signal, to alter it according to a specific, predefined rule. These gravitational oscillations we are detecting are the message itself. At our current level of development, we simply see planets, but perhaps that entire sequence is encrypted with information, mathematical constants, universal physical laws, or even a complete encyclopedia of knowledge. We are hearing the ring of an interstellar telephone, but we just don't yet understand the language being spoken to us. This would be the most magnificent message in a bottle in human history. Proponents of the artificial nature of the objects surrounding PSR B1257+12 point to several major peculiarities. First, there is the location itself. Why would anyone construct something near a pulsar deep within a zone of deadly radiation? The answer might be simple. For a civilization advanced enough to undertake such a project, radiation is a non-issue. Conversely, the pulsar's immense stability and power offer a unique, unparalleled advantage. Second, consider the ratio of the planet's masses. This configuration appears highly unusual for a standard, natural process of cosmic formation. Some researchers have noted that these specific parameters seem to adhere to a distinct mathematical regularity, a pattern seldom found in purely natural systems. Third, there is the overall uniqueness of this specific system. In decades of searching, we have discovered thousands of exoplanets. Yet, systems like this, with planets orbiting a pulsar, remain extraordinarily rare. Why is that? Perhaps it's because this isn't a natural occurrence, but rather an isolated, intentional artifact. Of course, all of this is purely speculative, but these anomalies force us to consider what if what we are observing is not what we think it is. Let's shift gears now, come back down to Earth, and examine this issue through a skeptic's eyes. Science adheres to a wonderful guiding principle known as Occam's razor, which states that entities should not be multiplied unnecessarily. Put simply, the easiest explanation that accounts for all the known facts is usually the correct one. So, in our specific situation, which explanation is simpler? Hypothesis. 1. Planets are orbiting the pulsar, having formed naturally from the residual debris disk left over after the supernova explosion. This entire process, while admittedly rare, adheres perfectly to the known laws of physics. Hypothesis. 2. A gigantic artificial megastructure is orbiting the pulsar, built by an unknown alien civilization for an unknown purpose. Clearly, the first explanation is vastly simpler. It does not require us to introduce a new, unproven entity, extraterrestrial intelligence. This is precisely why the overwhelming majority of scientists adhere to the planetary hypothesis. It is logical, elegant, and doesn't violate any established physical laws. Now, this doesn't mean it is guaranteed to be 100% correct, but until we have direct proof that these objects are artificial, the natural planetary version remains the primary, leading hypothesis. Let's take a closer look at these planets, or what we classify as planets. The closest one to the pulsar is Drauga. It's tiny, with a mass of just 2/100ths of the Earth's mass, making it one of the smallest exoworlds we've ever discovered. Next come two larger planets, Poltergeist and Phobetor. They are classified as super-Earths, each with a mass roughly 4 times that of our planet. All three are rocky worlds, but life as we understand it is completely impossible here. They sit squarely in the zone of the pulsar's intense radiation. Any atmosphere they might have had would have been ripped away long ago. Their surfaces are constantly being bombarded by high-energy particles. These are dead worlds, scorched and burned by radiation, If you were standing on the surface of one of them, the sky wouldn't be dark. It would glow with a chilling spectral light caused by the pulsar's radiation interacting with the remnants of the gas and dust disk. And hanging over this strange landscape, you wouldn't see the disk of a star, but rather a tiny, nearly invisible point sending lethal beams into space. A truly hellish landscape. The sheer uniqueness of the PSR B1257+12 system keeps scientists captivated and focused on continuous study. Its discovery triggered a veritable boom in the search for exoplanets. New methodologies were developed, and powerful new telescopes like Kepler and TESS were built. To date, we have discovered over 5,000 planets orbiting other stars. We've found hot Jupiters hugging their parent stars. We've found super-Earths, water worlds, and true ocean planets. We have even spotted Earth-like worlds residing within the so-called habitable zones. Yet the number of confirmed pulsar planets remains incredibly small. Only a handful of validated systems exist. This strongly suggests that their formation process is genuinely rare, demanding exceptional conditions. Or does it simply mean we're looking in the wrong place, or perhaps for the wrong things? Every new discovery in exoplanetology forces us to circle back to the very first, and perhaps the very strangest system, prompting us to ask the same persistent questions. What exactly is its true nature? Let's try to weigh the pros and cons of both hypotheses. The planetary hypothesis is supported by its simplicity and adherence to the laws of physics. We know protoplanetary disks exist. We know planets form from them. The second-generation theory seems entirely plausible. This hypothesis is further bolstered by the subsequent discovery of dust disks around other neutron stars, confirming that this entire scenario is indeed possible. So what are the counter-arguments? Primarily, they involve the statistical rarity of such systems and certain peculiarities in the orbital parameters and masses of the planets. But these are weak arguments. We still know too little about planet formation under extreme conditions to confidently say what is strange and what is not. It's entirely possible that for pulsar systems these very parameters are the norm. We simply have too small a sample size to draw proper statistical conclusions. So, what arguments support the artificial hypothesis, the idea that this phenomenon is engineered? The core concept itself is compelling, the notion that intelligent life might be leveraging the most powerful objects in the universe for their own purposes. Utilizing a pulsar as an energy source or navigation beacon represents highly logical and elegant engineering. Another point often cited in favor of this version is the system's apparent unnaturalness. However, that is highly subjective. To us, accustomed to the familiar structure of our own solar system, any other configuration might seem bizarre. The primary argument against this hypothesis, though, is the total absence of any corroborating evidence. Beyond the gravitational anomalies themselves, we have absolutely nothing, no other signals, no traces of activity. All we are observing is gravity, which can be produced by planets just as easily as by hypothetical alien megastructures. At this distance, we simply cannot differentiate between the two. Therefore, the speculative engineering version remains firmly in the realm of pure conjecture. This story is a perfect illustration of the scientific method at work. We start with an observation, an anomaly detected in the pulsar's signals. This leads to a hypothesis to explain it, the presence of orbiting planets. This hypothesis, in turn, generates predictions, for instance, that other planets should exist, or that a remnant debris disk might still orbit the pulsar. Scientists then conduct new observations designed specifically to test these predictions. In this particular case, the discovery of a third planet strongly bolstered the original hypothesis. However, there is always room for alternative explanations. Science never claims, "This is the absolute 100% truth." Instead, it states, "For the time being, this is the best explanation we have available." Perhaps in the future, with the advent of newer, more powerful telescopes, we'll be able to gather even more detailed data about the PSR B1257+12 system. Maybe we'll be able to resolve the planets themselves or confirm precisely what is causing those signals. And only then will we finally get our definitive answer. Until then, the mystery persists. Let's take a moment to reflect on the philosophical implications of this discovery. Even if these are merely planets, the sheer fact of their existence is staggering. It tells us that the universe is capable of forging planets in the most unexpected and seemingly inhospitable environments. It shows that planetary systems can be reborn from the ashes. This only makes the cosmos even more wondrous and diverse. But what if, just for a moment, we entertain the idea that this is indeed an artifact? That would immediately mean we are not alone. It would imply that somewhere out there, in the depths of space, a civilization exists, or once existed, so powerful that it could harness a dead star. That would change everything. It would completely overturn our understanding of our place in the universe. We would no longer be the sole intelligent species. We would simply become one of many. And the realization of that fact would undoubtedly be the greatest discovery in the history of humankind. This is precisely why scientists are focusing so intently on that distant speck in the constellation Virgo. So, where do astronomers stand today? More than 30 years after the initial discovery, the scientific consensus remains firm. The overwhelming majority of researchers are confident that Aleksander Wolszczan indeed discovered a planetary system, the first ever confirmed. This discovery stands as a monumental achievement, single-handedly ushering in a new era of astronomy, the age of exoplanets. The hypothesis regarding the artificial origin of these objects is dismissed as highly unlikely and purely speculative. It makes for interesting food for thought, great science fiction, but it is not regarded as a viable working scientific theory. Yet no one is ready to fully close the book on this story. In science, there are no definitive final answers. There is always the possibility that new data could force us to reconsider long-held conclusions. The PSR B1257+12 system remains under intense scrutiny. And who knows what further surprises it might hold for us in the future? Perhaps its biggest secret has yet to be revealed. Picture the scene. 23 quadrillion kilometers away, a tiny, super-dense stellar remnant is spinning. It's rotating at hundreds of times per second, sweeping the cosmos with invisible beams of radiation. Orbiting this cosmic monster, locked in eternal twilight, 3 dead worlds trace their silent paths. Worlds born from ash, worlds named after ghosts and demons. What are we looking at? Is this an astonishing cosmic quirk, proof that planets can arise even in the inferno of a dead star? Or is it a silent monument left behind by something unimaginably ancient and powerful? A massive machine perhaps functioning in perfect isolation for millions of years? We don't see the worlds themselves, we only see the shadows they cast, a slight ripple disturbing the perfect regularity of the pulsar's signals. And based on that faint shadow, we try to reconstruct the object that's casting it. It's like trying to understand what a person looks like by watching only their wavering reflection on the water. We can speculate and theorize, but complete certainty remains impossible. So, is it sheer coincidence, or is it something more profound? The truth, most likely, lies somewhere in the middle. What we are witnessing is an astonishing confluence of events, a vanishingly rare alignment of circumstances that somehow birthed a planetary system in a place where no system should logically survive. The improbability of this coincidence is so profound that it naturally gives rise to speculation about intelligent design. But until we have definitive proof otherwise, we are bound to classify this as a natural phenomenon, an astounding, unique event, one that fundamentally expands our view of the cosmos, but natural nonetheless. The true legacy of the pulsar PSR B1257+12 is not a story about little green men or ancient alien engineering. It is a testament to human curiosity. It's the story of one dedicated scientist who noticed a tiny anomaly in the data, refused to dismiss it as a simple error, and committed himself to uncovering the truth. In doing so, he made one of the most pivotal discoveries of the 20th century, opening the door for all of us into the vast world of other planetary systems. What lies beyond that door, whether it's more planets, megastructures, or phenomena we cannot even begin to conceive of, only time will truly tell. Our journey into the mystery of this enigmatic pulsar is drawing to a close. We've seen how tiny, almost imperceptible fluctuations in a radio signal gave birth to an entirely new field of astronomy. The story behind the discovery of the first exoplanets orbiting the neutron star PSR B1257+12 is a genuinely thrilling piece of scientific detective work. It began with an intriguing puzzle followed by a bold hypothesis that everyone initially dismissed as a mistake. Then came years of meticulous, painstaking effort to finally prove them right. And the result was a triumph that permanently altered our view of the universe. We realized that planets aren't cosmic rarities. They are a common, ordinary phenomenon capable of existing in the most improbable conditions imaginable. Yet the shadow of doubt, the haunting possibility of an alternative hypothesis suggesting an artificial object, still lingers over this entire history. It serves as a stark reminder of just how little we still truly know, and that the most incredible discoveries often await us exactly where we least expect them. Thank you for spending this time with me, delving deep into the mysteries of the cosmos. I hope this lecture hasn't kept you up, and perhaps even helps you drift off peacefully. Please subscribe to the channel, hit that like button, and definitely share your thoughts in the comments below. What do you think is truly orbiting that distant pulsar, planets, or something else entirely? Good night and sweet dreams.